example 2 in section 10.2. Says, when asked what do you think is more important, to protect the right of Americans to own guns or to control gun ownership, 46% of all Americans said protecting the right to own guns is more important. The research centers surveyed 1,267 randomly selected Americans with at least a bachelor's degree and found that 559 of them believe protecting the right to own guns is more important. Does this result suggest that the proportion of Americans with at least a bachelor's degree feel differently than the general American population when it comes to gun control? So again, we're testing a percentage. So we're going to assume that the proportion is the same, 0.46. We're trying to show that it's different from 0.46, maybe less, maybe greater, we don't know. Just trying to show if it's different or not. So we're going to run our test, stat, test, and then 1 prop z test. We have our x of 559. We have our n of 1,267. We have our alpha level that we'll use to make our conclusion. So stat, test, go down to 1 prop z test. This time we're testing against the null of 0.46. Our x was 559. Our n was 1,267. We're testing not equal to, so make sure to hit enter so that it changes to not equal to. And then go down to calculate. Gives you a z-score, which is called your test statistic, which I'm not as concerned about. It tells you how far away your sample is from your null. And then your p-value, the second number is what I'm concerned with, the 0.1794. That's the number you compare to alpha. So this time 0.1794 is greater than the 0.1, which is your alpha. So we fail to reject the null hypothesis. This is telling us that our sample did not fall in those extreme tails. So there is not sufficient evidence to support the alternative hypothesis that Americans with at least a bachelor's degree feel differently. So you always want to fill that in with the context of the problem. So we were trying to see if Americans with at least a BS degree feel differently. I guess that could be a BA as well. Bachelor of Arts or Bachelor of Science. All right, so that is testing with proportions. Hypothesis statements and conclusions are the hard part. The crunching of the numbers, we're going to let the calculator do all of it for us. So let's look at the same idea with means. Everything is the same, the setup is the same, the conclusions are the same, everything's the same, except we use the t-test instead of the z-test. So instead of the 1 prop z-test, we choose the t-test option. Everything else is the same. So these last two problems. The mean height of American males is 69.5 inches. The heights of the 43 male U.S. presidents, Washington through Obama, have a mean of 70.78 inches and a standard deviation of 2.77. So our sample was 43 presidents with an x-bar of 70.78 and a standard deviation of 2.77. And this is the true mean height of all American males. So treating the 43 presidents as a simple random sample, determine if there's evidence to suggest that U.S. presidents are taller than the average American male. And there's our level of significance. So we're testing an average. We're going to test against the 69.5. We're trying to see if the U.S. presidents are taller than 69.5. We're going to go to stat, test. This time we're going to choose t-test. So stat, test, I think it's the second option, t-test. It gives you two choices, data or statistics. Statistics is when you just have the values here. Data is when you actually have something to put into L1. We'll do that one here in just a minute. So this time we have statistics. The null we're trying to test against is 69.5. The x-bar we have is 70.78. The standard deviation is 2.77. We have 43 in our sample, and we're trying to test greater than. So when you choose statistics, sorry about the glare, you just put in everything you're asked. You got your null, you've got your statistics here, you've got whatever you're trying to test against, your alternative, and then down to calculate. It gives you a t-score. Again, I'm not as concerned about that, but they call that the test statistic. That again tells you how many standard deviations away the sample is from the mean. If you want to learn more about that, you can read about it in your textbook. I'm concerned with the p-value, 0.0021. We're going to compare 0.0021 to alpha, 0.05. It's less than 0.05. And if the p-value is less than alpha, we reject the null hypothesis, which means there is sufficient evidence to support the alternative that the U.S. presidents are significantly taller. All right. Hopefully you're getting the hang of this. I try to keep it as simple as I can for this last chapter. Last example, it says the fun size of a Snickers bar is supposed to weigh 20 grams. Because the penalty for selling candy bars under their advertised weight is severe, the manufacturer calibrates the machine so that the mean weight is 20.1. So that's what we're really focusing on here. That's what the machine should be reading. The quality control engineer at M&M Mars, the Snickers manufacturer, is concerned about the calibration. Just concerned. He doesn't think it's right. He obtains a random sample of 11 candy bar weights, weighs them, and obtains the data in Table 1. So here's the actual weights of the 11 candy bars. Should the machine be shut down and calibrated? Because shutting down the plant is very expensive, he decides to conduct the test at a very low level of significance, which means the value has to be very extreme in order to shut down the machine. So the mean should be 20.1. He just wants to know if it's not 20.1. Is it off? Could be too small, could be too big. Is it off? So anytime we're given raw data, we're going to put that raw data into L1. So go ahead and put all of those values in L1. So stat, edit. If something's there, push clear, enter at the top. So let's put those data points in. There's 11 data values, so your cursor should stop at 12. There's so much glare. Alright, so your data is in L1. Now we're going to go to Stat, Tests, go over to T-Test again, but this time we have the data. So switch to Data, hit Enter. We still need to know what we're trying to test against, which is 20.1. Our data are in L1, our frequency is always 1, and we're testing not equal. So a two-tailed test. So when you choose data, it just needs to know what we're trying to compare it against and what direction we're trying to test. Go down to calculate. It will do the rest of the work for you. So again, the homework's going to want the t-score, or the test statistic is what they call it. And then the p-value is what I want you to focus on. 0.3226. So we're going to compare that number to alpha. It's definitely greater than 0.01. And so because it's greater, we fail to reject the null hypothesis, which means there is not sufficient evidence to support the alternative that the machine should be calibrated. So So given with this sample, they're saying, then the machine's not off that much, so it's okay. All right, and that is it for Chapter 10, short and sweet.